In this lesson, we'll introduce absolute values. So in Introduction to Absolute Values, there's sort of an informal definition that says the absolute value or a real number can be regarded as the distance of the number from zero on a number line. So if we think of that definition and we look at determining the absolute value of a number, for example, the absolute value of 3 would of course be 3 because the distance on a number line, of course, from 0 to 3 is 3. Or the distance on a number line from 0 to -7 would be 7. The distance of -7 from 0 would be 7. So the absolute value, therefore, of -7 is 7. If we look at sort of a fancier definition up here, sometimes called a piecewise definition, the absolute value of a number would be that number if the number is positive. So for example, if a is greater than or equal to 0, let's just make a number like let a equal +2. Then the absolute value of 2 would of course be 2. If the number is negative, for example, let's just do this in green, let a equal -2, then the absolute value of -2 is the negative of -2, which is +2. And that's all this means. If our number is negative, the absolute value is the negative of that number. Okay, so it looks kind of like a fancy, weird definition, and it's really not. It just means if it's positive, it is that number. If it's negative, it's the negative of the number. Okay, it's the opposite of the negative. So your term, evaluate the following. Absolute value of 9 is of course 9. Absolute value of -12 is of course 12. And the distance from 0 to itself is of course 0. Okay, write the real numbers in order from least to greatest. So what I want to do here, if there's an absolute value, I want to take the absolute value. So for example, the absolute value of -6.5 is 6.5. Okay, let's just get rid of those equal signs to make it a little more condensed here. There's our 6.5. There's 5. 4.75 is the absolute value of 4.75. Okay, -3.4 is of course -3.4. -12 fifths as an absolute value, that would be a +2.4. And we could just pop that into our calculator, but 2 fifths is 0.4. 2 fifths is the same as 4/10. Absolute value of -0.1 is of course +0.1. And this isn't the absolute value, so that stays the same. And the absolute value of -2.5 is +2.5 as a decimal. So I'm just writing them all as a decimal just for comparative purposes. So we've got this negative value and this negative value. Which of those would be smaller? Of course, -3.4 would be smaller. Okay, and we can just number those as well. This would be the smallest. We went from least to greatest, so I'm going to make sure I double check that, because sometimes on a test you'll see greatest to biggest, or greatest to smallest, which is sort of mean. So -3.4 is of course our smallest. There's our next bigger number. The next bigger number here would be this one right here, 0.1, and then of course 2.4 rather, 2.5, 4.75, 5, and 6.5. So there's our numbers, sort of, we'll just list those out there. -3.4. The next one was -0.01. Absolute value of 0.1 negative. Okay, absolute value of 12, -12 fifths. Absolute value of -2.5. Absolute value of 4.75. 5, and then the absolute value of -6.5. Okay, there's our numbers there in order, okay, from smallest to biggest. Let's take a look at the next example. It says evaluate the following. So it looks like we always get a positive number, right? Well, not always, because if you've got something like the absolute value of 4, which is of course 4, subtract the absolute value of -6, which in itself is 6, but then 4 minus 6 is, of course, negative 2. Okay, so just because an equation has an absolute value symbol in it doesn't mean our answer is always going to be 100% positive, right? Depending on the order that we're adding and subtracting. So this is like saying 5 subtract 3 times the absolute value of 2 minus 7, which is negative 5, which is 5 minus 3 times the absolute value of negative 5, which is then positive 5. So that's 5 minus 15, which is negative 10. Okay? And the next one, let's just look at our order of operations. So I still want to do my brackets and my exponents first. So I've got the absolute value of negative 2. 5 minus 7, that's a negative 2 squared plus 6. The last thing we're going to do is take the absolute value, kind of working from the inside out here. So we've got the absolute value of negative 2 times 4, because negative 2 squared is, of course, 4. And then, of course, negative 2 times 4, that's the absolute value of negative 8 plus 6, which is the absolute value of negative 2, which is 2. So I kind of baby stepped that a little bit. If you wanted, you could do this on your graphing calculator. So if we go into my graphing calculator here and turn this on, I think it's on. If I go into math, arrow over to number, and number 1. Same as the TI-83s, math, arrow over to number, and then it's number 1 absolute value. And then I forget what we just had there. What did we just have there? We had, let's just do the second one here. 5 minus 3 times the absolute value of 2 minus 7. So that was 5 minus 3, whoops, let's clear that. 5 minus 3 times the absolute value. What was that? Of 2 minus 7. I think I'm getting Alzheimer's. I'm just old, you guys. There we go. And if we push enter there, there's our value, negative 10, okay, which is what we had just a minute ago. So you can see how you can do that with your graphing calculator as well. Okay. Absolute value of 4 minus the absolute value of 3. I mean, by the time you plug it in, something like this is faster just to do it in your head, right? Absolute value of negative 4 is 4 minus the absolute value of negative 3, which is 3. So 4 minus 3 is 1. This is the absolute value of, just think there's kind of like little brackets around there, right? That's a negative 4 if we simplify that. And of course, the absolute value of negative 4 is 4. And this last one here, absolute value of 12 times negative 3, which would be negative 36 plus 25. Okay, and of course, negative 36 plus 25, that's negative 11. And the absolute value of negative 11 is 11. Okay, so I'm going to let you go ahead. And if you're looking at what homework questions to do, if you look at the assignment book, questions 1 to 11 would be great. Okay, if you get stuck on any of those questions, please feel free to contact me. Thank you.